yesterday we looked at the area of a trapezoid and how the formula is made. We drew that little diagram at the end of class. And now, if we had a curve, and instead of either using the right side or the left side, which made rectangles that were bigger, it'd be like, well, if you connected those 2 points, the left side and the right side, and drew a trapezoid, so trapezoid has 2 parallel sides, and the parallel sides are now the heights. And it has one base, which is one height, and the other base, which is the other height. And if you wanted to find the area of this, you would just take the average of those 2 heights and multiply by your change in x along the block. And what you can see with drawing the trapezoids is you're like, ooh, that actually is pretty accurate looking already as far as an area goes. And the trapezoid sum is always the average of the left and the right. So you can find the trapezoid sum in 2 different ways. You can find all the lefts, you can find the right sum, and then just take both those answers and cut it in half. You will always get the trapezoid sum, because the trapezoid sum is always averaging out the max and the minimum. It's not necessarily the same as the midpoint sum, right? Because you see how the midpoint is at different heights along the way. So, those are the 2 options. You could either do the left and the right and get the average, or you can find it separately. So we're going to find the trapezoid sum for 4 subintervals from 1 to 2 of sine x divided by x. So our change in x is 1/4. If we actually draw out the intervals in interval notation, we have them there. Left sums, all of them are 1/4, so you just plug in the left value points along the way. Save yourself time on calculating, and I'll do the same thing, show you the right sums as well. So if you just average those 2, you would get your trapezoid sum. When you draw out the intervals, I put little L's and R's under each of those. Can you see that when you're doing the left sums, you're using the left numbers? And when you're doing the right sums, we're using the right numbers. Or option 2, you could actually find each one by doing f of 1 plus f of 5 divided by 2 times 1/4. And you'll get the exact same thing. I kind of like the left and the right, because if ever you needed one of those other answers, then you've already figured it out. So it's sort of like it feels like you figured out 3 things. If you do the method that uses the left and the right, you found the left sum, you found the right sum, and you found the trapezoid sum. But you could use, this is just using the formula of a trapezoid. Base 1 plus base 2 divided by 2 times the width of that trapezoid. Find the left Riemann sum, the right Riemann sum, and the trapezoid sum from 1 to 3 with 5 subintervals. So they're not beautiful subintervals if you take that and divide it by 5. The distance between 1 and 3 is 2. If you divide it by 5, does it make sense that each one is 2/5 wide? So you're going to go 1, and if I added 2/5 would get me to 7/5. Then 7/5 to 9/5, 9/5 to 11/5, and so on until you get to 3. Your change in x is 2/5. The left sum, you would use all of the left numbers. The right sum, and it's a little bit annoying because you're going to have to plug in e to the 1. If you plug in 7/5 for x, do you see that you would get e to the 49 over 25? And we have all of these numbers, which, if you evaluate them, and then the trapezoid sum would just be the average of those two. And judging how different the left and the right are, I would guess that the trapezoid is a much better, much more accurate attempt. Are you done? No? Okay, I'll go back. I so badly want to start the activity because there we go. So we're given the following charts of velocities. So these are values of velocities. Velocities are a rate of change of displacement. In the video that we watched with Mr. Bean together, if you have a graph of a rate of change, and these are values on the graph of a rate of change, then the area under the curve is an accumulation of change and how much the displacement has changed. So that's the big idea here, but if you read that question and don't have that big idea, you'd be lost right away. So you're given the following chart of velocities at different times. Estimate the displacement. Well, we don't have the actual equation. What's the best way to estimate it? We can use sums. And this question says, can we use trapezoid sums with 4 intervals? Well, we do. We can go from 1 to 3, 3 to 4, 4 to 8, and 8 to 9. Even though those aren't the same width, that's the best that we have. So those are our 4 intervals. And displacement will be the accumulation of change, or the area under the curve, of your velocity. So we can use our left points and our right points. And notice this time we don't factor out because each of the widths are different widths. So the left points, you would plug in the 1, the 3, the 4, and the 8. And the right points, you plug in the 3, the 4, the 8, and the 9. And we get a left sum of 27. Plugging in our right values, we get a right sum of 15. So our trapezoid sum, the best estimate that we can do is that based on those velocities at those times, we could say it has traveled about 21, what are the units? Give us units in this one? No. So we can't even put units.